All right, hello. Welcome to the 3C day 2 notes. I will be going over just a quick rundown of this first page here. Want to help you do some of these fill-ins. The pages are numbered in this packet, but this is the day 2 notes. And as you can see on the slide before, these are transformations that do not change the shape of a graph. They only change the location of the graph. So we're going to take these functions and move them all different ways around, but at the end of the day, they're still going to look exactly the same, just where they are in the coordinate plane will have changed. So the first type of transformation that we can do is called a vertical shift. This would represent a translation up k units. You can see that k is happening on the outside of the function. Similarly, we have a translation down k units. And some of these might seem a little familiar, others not. So when you have a plus on the inside, it is a translation left k units. And this is going to be a translation right. And of course, k units, whatever direction that's in. So this last one is the two different types of reflections that we can have. So I want you to think about what this notation looks like, and then try and imagine what it does to a graph on a coordinate plane. So if we happen to have a point, let's just call this A comma B. All right. So look where that negative sign is. It's on the outside. So if it's on the outside of the function, that means that the y coordinate is going to become negative. See how the x is still just x? So this would be a reflection, and we would have negative a comma b, and then a comma negative b. So we're going to explore both of these translations, both of these reflections at a later time. You're going to see though down here, right, in this little box, we can explore the first type of reflection in this video, and then we'll do the other type of reflection in the next. So it's kind of our job right now to figure out if the negative's on the outside, which point is that, right? If the negative's on the inside, which point is that? So we need to figure out what type of reflection this is. So I am going to nestle myself right up here. Okay, so we've got a graph. F of x is the absolute value of x plus 3. So we would plug that in, and we get absolute value of negative 5 plus 3, which is the absolute value of negative 2, which just equals 2. So we're going to have negative 5 comma 2, 1, 2, 3, 4, 5, and 2 up. And then the same process is going to follow. So this would be absolute value of negative 1. That's just 1. Absolute value of 0 equals 0. And then it's going to go bounce back up here. So negative 2 plus 3, that's absolute value of 1. So the output is going to be 1. And then this one will be negative 1 plus 3 for an absolute value of 2. And that's what we're looking at. So that right there, we can do a little color coding here. So that's the original. And dotted lines here too. That look nicer. Okay, awesome. So now we're going to shift over, and if there's a negative sign outside the absolute value, that means that we have to take whatever value we were given as an output, and we're going to negate it. So instead of having 2 as our output, we're now going to have -2. So we're going to have the point -5 comma -2. We'd have -1 over here to get -4 comma -1. This is still going to be 0. So this would be -3 comma 0. But the output was 1 here. Now it's going to be -1. So we have -2 comma -1. And then this was a 2, so it's now going to be -2. And we have -1 comma -2. So -5 comma -2 is right here. -4 comma -1. -3, 0. And so on. So you can see that when we put that negative sign outside the function, it flipped over the x-axis. So now we can kind of go back to our general model, and I'll move myself here. Okay. So with all this in mind, now we kind of realize that the outside, that is related to the y coordinate. So when we took AB and we put the negative on the output value, it flips it over the x-axis. So this represents a reflection over the x-axis. And we'll use a little bit of deduction here. This one's going to be over the y-axis. And to get that video, you'll go to the next slide, and we'll start doing a couple more. Okay? Let's go back here.